Welcome back, everybody. In this video, we are going to introduce displacement in two dimensions. If you recall, displacement is defined by the change in position or how far the object is from where it started. Previously, displacement was exclusively talked about in single dimensions, whether it was in the x direction or the y direction. Moving forward, the focus will be on objects moving in both dimensions, and vectors become really useful. We're going to recall a couple math concepts and start with the Cartesian coordinate system. If the object moves along the x-axis, directions could be left and right, west and east, or forward and backward. If the object moves along the y-axis, they could be north and south, or up and down. However, it is very likely that an object moves in both dimensions, like north and east. Let's recall another math concept, the Pythagorean theorem. A squared plus b squared equals c squared. Remember that the Pythagorean theorem can only be used on right triangles. A and b could be the base or height, but side c had to be the hypotenuse. How does this transfer to 2D displacement? In math, A, B, C were just sides of the triangle and may not have represented more. In physics, those sides could represent displacement. A now represents delta x, B represents delta y, and the hypotenuse d is a displacement in two dimensions. It's still the Pythagorean theorem, but with physics variables. The Pythagorean theorem can be modified so that it works for velocity or acceleration, but for the sake of this video, we'll stick to displacement. Let's move on to an example. A person travels east 3 meters and then north 5 meters. What is the displacement? Let's draw a vector for each displacement. We'll draw a vector to the right for 3 meters east. We'll draw a vector up for 5 meters north. Notice these vectors are connected as it represents the person's path. The hypotenuse is the displacement, which if you look at it visually, it is the line representing how far the person is from the starting point. We know how to find the hypotenuse through Pythagorean theorem. Let's plug the values in. 3 meters squared plus 5 meters squared equals displacement squared. This gives us 34 equals displacement squared. We're going to have to square root both sides. Displacement comes out to be 5.83 meters. But wait a minute, we're not finished because the direction is missing. You might say the direction is simply northeast. While that's somewhat true, northeast is a vague direction. Let me show you why. This vector points northeast, and so does this one, and this one. To differentiate from all these variations, an angle is needed. The angle we'll be solving for is located right here. To solve for this angle, a trig function will have to be used, and I'm going with the tangent function. Since all sides are known, sine and cosine are also viable options in solving the angle. Make sure your calculator is in degrees first. Tangent of the angle is equal to the opposite over the adjacent. In this case, the opposite side is delta y, and the adjacent side is delta x. Tan inverse of 5 over 3 gives us an angle of 59.03 degrees north of east. It's north of east because the angle is located north of the east direction. It is possible to express the answer as east of north, but I am not going to go over it yet as it might cause confusion. Going back to complete the answer, the displacement is 5.83 meters at 59.03 degrees north of east. The last notes I want to end on is about direction. If a displacement or any vector quantity has a direction of northeast, southwest, southeast, or northwest, it means the angle is exactly 45 degrees. Hope you found this video helpful, and thanks for watching.